Hello students, today we will discuss about nodes and antinodes formed when stationary waves are produced. Nodes and antinodes. As we have studied that whenever a pulse is generated at an end of a string and it travels towards the rigid end where the string is attached, and after the reflection the pulse reflects and comes back to the sending end. Now as we have worked out to find out the displacement equation of the stationary waveform, which is given by stationary wave produced by superposition of two waves is given by, say, y, that is the function of position and the time, equals to 2a kx multiplied by cos omega t. The above equation, in the equation given above, 2a sin kx is expressed as maximum displacement of an element at position x. Now, here there are two conditions for the value of kx. The first is if kx equals to n pi, then amplitude of element will equals to 0, because the value of sin kx, which is sin n pi, will be given 0. And also we know that kx uh, k equals to 2 pi upon lambda, where lambda is the wavelength of the wave. Then 2 pi upon lambda multiplied by x will be equals to n pi, and that will give the value of x in terms of lambda, which will be n lambda by 2, where the value of n will 0, 1, 2, 3, 4 and so on. So the each position of the particle or you can say the element corresponding to x equals to n lambda upon 2 is called node, and at each node the maximum displacement of the element will be 0, or you can say the amplitude of the element will be 0. Now similarly, if kx has the value 2n plus 1 bracket multiplied by pi by 2, the amplitude of element will be maximum, and that will be equals to 2a, because the sign term will have the value maximum value 1 or the minus 1, so its magnitude will be 2a. Now in this case we can write here x equals to 2n plus 1 bracket multiply by lambda upon 2, and the position of the element corresponding to the value of x here is called antinode. Thus we can say that the separation between two consecutive nodes or antinodes is lambda upon 2. Now in case of a string, fixed at one end, the fixed position B the position x equals to 0, and the other end of a string x equals to L. Since the length of the string we are considering L. L is the length of a string. Then for a node formed in a string, for a node position, L will be n lambda upon 2, n lambda upon 2, or we can give the value of lambda in terms of length of the string, that will be lambda equals to 2L upon n. We can give the value of lambda in terms of length of the string, that is 2L upon n, and the corresponding wavelength will be, and the corresponding frequency of wave can be given by n equals to v upon lambda, that will be equals to corresponding frequency of wave f will be equals to v upon lambda, will be given by n multiply v upon 2L, where v is the speed of wave. The frequency expressed above are called natural frequencies, or mode of oscillation of the system. Mode of oscillation. The mode of oscillation with lowest frequency, which is for n equals to 1, is called fundamental wave of frequency. Is called fundamental wave of frequency. Fundamental mode of frequency, or can also be expressed as first harmonic. Similarly, second harmonic is concerned to n equals to 2, and so on. The collection of all possible frequencies mode is called the harmonic series. Harmonic series. So that's all for today. Thank you.